Welcome to the EUMETSAT Year of Weather video for 2025. We start the year with an active tropical cyclone in the southern Indian Ocean. This is Cyclone Dekelde, and this storm will travel across the Indian Ocean, over Madagascar and towards Mozambique. It's not an unusual time for storms in this season to form. They're fueled by the warmth of the tropical ocean, and you'll see that they curve round towards the pole towards the end of the line. At the same time, we have the Northern European winter storm season. So here on about the 21st of January, the storm Eowyn, which travels across the UK and Ireland and then over into Scandinavia. This is one of the strongest windstorms in a decade. So two dominant weather patterns to look at: the formation of the tropical cyclones in the tropical ocean. So you see those very intense areas of circulation. Those storms are fueled by the warmth of the tropical ocean. Of course, it's winter in the northern hemisphere, summer in the southern hemisphere, and that heat is really great energy to just energize these storms and keep them going. In the north, we are controlled by the difference in temperature between the tropics and the poles, the cold poles for the winter. And that's what's driving those storms, in the European case, across the Atlantic, coming over and then traveling over the continental area. We use the storm names to help people be more aware of the impact of the storm. So weather services around the world will name a storm when it's going to have particular impacts for citizens, usually strong rain or strong wind. The storm is named, and then there will be a warning based on a colour scale, yellow, red, to give people information about what to do, how to act in order to stay safe. And what can happen with these storms is the position of the jet stream will determine exactly where they pass. At the moment, we have them passing very far to the north in Europe. And actually in March, coming into April, we had one of the sunniest Marches on record. So satellite data are really important in measuring things like the amount of sunshine hitting the surface of the Earth, the energy available that's there to warm the oceans, to warm crops, and to warm the land. Over the land, we also have really important surface observations. So weather services around the world are measuring the amount of sunshine that hits these weather stations, and that's also used to compare with the satellite record so we can check that the satellite record is correct. What the satellite record brings is the truly global record that you're seeing here. So we're now moving into May. If you're looking at the centre of the image, what you'll see is this pulsing band of cloud. This is the intertropical convergence zone. It's where air from the north and the south meet and rises going up. What's happening here is you have heating on the surface, which is partly causing that rising, and it's where you have the strong tropical rainfall. If you watch the season as it evolves, what you'll see is that gently moving to the south as we move from northern hemisphere winter into spring and then into summer. In many parts of Europe, May saw one of the sunniest springs on record. And you can see that here with the number of sunny days or cloud-free days that you'll be seeing, particularly in the southern parts of Europe. As we move into June, we're getting into one of the first heat waves of the European summer. These heat waves are of a particular concern to the weather services, monitoring the build-up and the breakdown. Heat waves affect the most vulnerable people in our societies, particularly old people or ill people who need a bit more support. And in those hotter periods, finding places to stay cool and get what they need to stay healthy and fit. So as we move into the northern hemisphere summer, in the southern hemisphere, you'll see now a lot more of those cloud structures traveling across the southern oceans. These are the building up of the winter storm season for the southern oceans. And you can see where there's less land, those storms have much more opportunity to travel unimpeded across the southern oceans and can be really quite intense. Just take a moment to look at the direction of the flow of the wind around the Earth. So what you might notice is in the tropical belt in the centre, you have the flow going from the east over to the west. Whereas towards the pole, that direction is reversed. And it's one of the features of living on a rotating planet. It's the Earth's rotation that causes the storms to move in these particular directions and patterns. It's quite amazing to have this global view of the world's weather. And it comes from the international collaboration that happens between the weather satellite organisations who share their data to support the role and the task of the weather services. And what we actually have in front of us is the infrared view. It's why we don't see from this view the particular change in day and night. You can infer it from that pulsing of the clouds in the tropical region. During the day, the land surface is heated, the air rises, which triggers those thunderstorms, they decay a bit overnight, and then they build up again. But the infrared view, what we're looking at is the temperature on the top of the clouds as detected by the satellites. The brighter white areas are the colder clouds, the more misty white areas tend to be the warmer water clouds slightly lower down. We've put this over a view of the Earth that's a historical record of the land surface and how it changes. So the greens and the desert colours you're seeing are not real, they come from the background imagery. So as we move into September, we're now into the beginnings of the Atlantic cyclone season. Atlantic tropical cyclones are born in these waves that travel across Africa. They will then come over the Atlantic Ocean. If there's enough warmth there and the storm starts to organise, it will then start to rotate, get fueled by the warm water, and then stabilise and stay as a hurricane. So you can see those storms. They might be named in the middle of the Atlantic or slightly closer to the land, depending on when they reach their peak intensity. And you'll see that many of them will start their journey travelling over towards the Caribbean, and then maybe travel north. They might then curve into the continental United States, or then travel across the Atlantic and then become a European storm. So you might sometimes in Europe hear a storm referred to as ex-tropical cyclone or ex-hurricane, and this is when those storms have gone through that process. So the lifetime will be quite some many days where it started, it was born off the coast of Africa, travelled over the middle Atlantic towards the Caribbean, and then curved back over towards Europe. You'll also see some storms being born off of the west coast of the US and also in the Gulf region. So we also see at this time of year the tropical cyclones being formed in the Pacific Ocean and Indonesia region. The tropical cyclone forecasting for this region is very well coordinated between the different countries because the storms will form in the Pacific region, travel and can affect a large number of different countries. And it's very important that people have consistent warnings and consistent information about what those storms are going to do. And so now we're back to the similar weather patterns we were starting to see at the very beginning of the year. The summer in the southern hemisphere, the tropical storm belt moving across the equatorial region, and the winter storms travelling across Europe. October and November was one of the least sunny periods for quite some time and quite some years in Europe. So we're now leaving 2025 and heading in towards 2026. For EUMETSAT, this will be the start of our 40th year. So that's 40 years of observing the Earth and passing that data on in real time to people providing services and doing science around the world. But we also have that whole record as a climate data record. But a question for you. Over the last 40 years, what have been some of your most memorable weather moments? Do post them in the comments below, and thank you for watching.